Welcome to solverfy.
All right, on question 46, we are given the compound fluorocarbon. So that's a fluorocarbon C2Cl3F3. And we're told that it has a normal boiling point equal to 47.6 degrees Celsius. And this gives us the specific heat of the liquid as well as the specific heat of the gas. So the specific heat of the liquid is equal to 0.91. That's joules per gram Kelvin. And the specific heat of the gas is equal to 0.67 joules per gram Kelvin. And then the heat of vaporization is equal to 27.49 kilojoules per mole. And they want us to calculate, so we have 35 grams of our substance, and they want us to calculate the heat required to convert this 35 grams from a liquid at 10 degrees Celsius to a gas at 105 degrees Celsius. All right, so there are going to be 3 steps to this problem. In step 1, we're going to warm up our liquid from 10 degrees Celsius to the boiling point of 47.6 degrees Celsius. In the second phase, we're going to vaporize it. So we're going to take it from a liquid to a gas. And in the third step, we're going to heat up our gas from the boiling point of 47 degrees Celsius up to the required temperature of 105 degrees Celsius. So let's start with step 1. In step 1, again, we're warming it up. And so for that equation, that's a Q equals MC delta T equation, where the mass is the 35 grams. The C is the C for the liquid, because right now we're at a liquid, so that's 0.91 joules per gram Kelvin. And then delta T is T final minus T initial. Now, this is per Kelvin, but the size of a Kelvin degree is the same as the size of a Celsius degree. So if you were using absolute temperature, you would have to convert to Kelvin. But since we're doing a change in temperature, we can actually do that in degrees Celsius. It'll be the same as a change in temperature in degrees Kelvin. So I'm going to say 47.6 degrees Celsius is my final temperature minus the initial temperature of 10 degrees Celsius. And I get 1197.56 joules. I'm going to divide by 1,000 to convert that to kilojoules and take it to 4 sig figs for now, 1.198 kilojoules. So that's the amount of energy for step 1. In step 2, we are vaporizing. So the heat required for that is going to be equal to the delta H of vaporization. And since that is per mole, we're going to have to multiply that times the number of moles that we have. So I'm going to need to convert my 35 grams of C2Cl3F3 into moles. And the molar mass of that is 187.5 grams. So I get the number of moles is equal to 0.187 moles. So I'm going to come over here, and my heat is equal to my heat of vaporization, which they gave me was 27.49 kilojoules per mole times the 0.187 moles. And that is going to be equal to 5.14 kilojoules. Finally, I'll come over here for step 3. In step 3, we are again warming it up from the 47.6 to the 105. So I will again use my Q equals mc delta T equation, where m is still 35 grams. C in this case, now I have a gas, so I'm going to use the specific heat of the gas, which is the 0.67 joules per gram Kelvin. And my change in temperature now is 105 degrees Celsius minus the 47.6 degrees Celsius. And for that, I'm going to get 1,346.0 joules, or 1.346 kilojoules. And now I add all three up and I get a total. I'm going to round my total to 3 sig figs. Now I'd like to keep more than the right number of sig figs if possible until it's time for the final answer. So I round my final answer to 3 sig figs and I get 7.68 kilojoules.